welcome you all to Think Max. We are in Class 11 Max, Chapter 4, Complex Numbers and Quadratic Equation. In this session, we are going to discuss about the basic concepts involved in this chapter. Okay, what is a complex number? How we can solve it. Already in 10th standard, you have studied quadratic equation and you all know how to solve a quadratic equation. You can either factorize or use the quadratic formula. So what is the formula? It is nothing but x is equal to minus b plus or minus square root of b square minus 4ac divided by 2a. So this is the quadratic formula to solve the quadratic equation. So now what we will do, this b square minus 4ac, it is called the determinant. If it is equal to 0, the solution will be equal. That is real and it will be same, that is equal. If it is greater than 0, then also the solution will be real but distinct. We will get two type of solution. Suppose b square minus 4ac is less than 0. What we will say? We will say no real solution. So this is what we learned in 10th standard. Now take this quadratic equation, x square plus 1 is equal to 0. Now what will happen? Keep this x square as such. If you take this plus 1 to right side, plus 1 will become minus 1. So now what we will say? This power 2 will not have negative real solution. Okay. So we will not find out the solution. We will stop as no real solution. That means it has imaginary solution. Okay. It has imaginary solution. That's what we will be dealing in complex numbers. Okay. This imaginary solution is denoted by a letter I. Okay. Iota. We will say it as iota. Okay. So this minus 1. So here x square equal to minus 1. So taking square root on both sides, what will happen? The square root and power 2 gets cancelled. So x will be equal to root minus 1. So this root minus 1 is denoted as I. Okay. So root minus 1 is denoted by I. I is nothing but it is called iota. Okay. So it is denoted by I. Now if you square on both sides, if you take square, what will happen? Minus 1 will be equal to, so that is root of minus 1 is I. We are denoting root minus 1 by I. So what will happen if you take square on both sides? If I am taking square on both sides, okay. So the square root and power 2 gets cancelled. So minus 1 equal to I square. So that is I square takes the value minus 1. Okay, so this is one important concept you have to remember. That is I square is minus 1. So with this concept, we are going to learn all the concepts involved in complex number. In the complex number, you will have an imaginary part, that is I. So now how to write a complex number? Okay, how to write a complex number? A number of the form a plus ib. So we should write a complex number in the form a plus ib. So this is the notation for complex number. Complex number is denoted by the letter z. That is z equal to a plus ib. For example, you have 2 plus 3i minus 6 plus 7i, 3 minus I 9. I can be written in the back or front, but it is A. This is A and this is B. Okay. Here this A is called the real part of Z and this 9 is called the imaginary part of Z. Here also you have minus 6 is the real part and this number which is the coefficient of 7, which is the coefficient of I, that is 7. 7 is the imaginary part. So we will say as real part is nothing but real part of Z is A and imaginary part of Z is B. Clear children? So find out the real part and imaginary part means you have to write in this form. Now to convert this to a plus ib, how to write this number? It is 3 plus I, and you have to write minus 9. Now this is A and this is B. So real part of Z is 3 and imaginary part of Z is minus 9. Okay. Here this is A and this is B. So real part of Z is minus 6 and imaginary part of Z is 7. Here it is of the form A plus IB. So real part of Z is 2 and imaginary part of Z is 3. So to find out the real part and imaginary part, you have write it in the form A plus IB. Okay, if you write it in the form, A will be real part and B will be imaginary part. Clear? So let us move on to the next concept. Equality of complex number. So this is simple, very simple. We will say two complex numbers are equal. Let us take the complex numbers as Z1 equal to A plus IB and another complex number Z2 is equal to C plus IB. They are saying these both are equal. When will they be equal means if this real part A and in the another complex number we have the real part C. If A and C are equal, and the imaginary part, who is that? It is B, and in this Z2, D is the imaginary part, and B and D should be equal. Okay, so if it is so, we will say the two complex numbers are equal. Clear, children? So for example, let me take an example. So it is nothing but suppose Z1 equal to 3 plus I6 and Z2 is equal to 3 plus I6. So if you check, both have the same real part. A is equal to 3 for both. And also for B. Who is B? It is this B. B is also same. 6 for both. If it is so, we will say it as Z1 is equal to Z2. That is, these two complex numbers are equal. Clear? Another example. Suppose if Z1 equal to 6 plus I5 and Z2 is equal to 5 minus I10. Okay, 5 minus I10. Now here A is equal to 6. That is A1 equal to 6 and B1 equal to imaginary part which is 5. And here A2 which is the real part, it is 5 and imaginary part is, it is not 10, it is minus 10. We have to convert this to 5 plus minus 10i. Okay, so B will be minus 10. So B2 is minus 10. Here A1 is not equal to A2 and B1 is not equal to B2. So we can say Z1 is not equal to Z2. Okay. Now one more example. Suppose Z1 equal to 7 plus I6 and Z2 is equal to minus 7 plus I6. Now what is the real part here? That is A1. For Z1, A1 equal to 7, B1 equal to imaginary part which is 6. The same way for Z2. What is the real part? It is minus 7 and what is the imaginary part? It is 6. Is the real parts equal? No. The real part is one is positive, one is negative. So A1 not equal to A2 but B1 equal to B2. But both should be equal. What is the definition? They are equal if real parts A and C are equal, imaginary parts B and D are equal. Even though here imaginary part is equal, real part is not equal. So these two complex numbers are not equal. Clear, children? Only if both real part and imaginary part are same, then we can say the two complex numbers are equal. Clear, children? So moving on to the next concept. Addition of complex number. How to add the complex number. So there are two complex numbers. Z1 equal to A plus IB and Z2 is equal to C plus ID. So there are two complex numbers. To add these two complex numbers, what we have to do? We have to add the real part. Okay, real part of Z1 plus real part of Z2 plus I into, you have to add the imaginary part of Z1 and imaginary part of Z2. So this will also be a complex number. These are the form A plus IB. So addition, adding the complex number, its result will also be a complex number. Okay, children. So let us take an example. So for example, Z1 equal to 6 plus I8 and Z2 is equal to minus 5 plus I9. So what is Z1 plus Z2? What is that? First we have to add the real part. So real part is 6 here, minus 5 here. So 6 plus minus 5 plus I into, what are the imaginary parts? 8 and 9. So it is 8 plus 9. So 6 plus into minus is minus. So we will get 6 minus 5 plus I into 8 plus 9. What is 6 minus 5? It is 1. So 1 plus I, 8 plus 9 is 17. So 1 plus I 17. This is also a complex number. Okay, clear children how to add the complex number? Now let us see properties of addition. So first property is closure law. What is closure law means? If there are two complex numbers Z1 and Z2, then we will get their addition. That is Z1 plus Z2. It also belongs to a complex number. So this complex number is Z. Okay, not a Z will not for integers. So suppose if Z1 and Z2 are complex number, then their addition will also be a complex number. Clear children? Next one is commutative law. What do you mean by commutative law? That is if we are adding two complex number Z1 plus Z2, that will be equal to, if you add in this way, Z2 plus Z1, both will be same. So just check this example. We have Z1 plus Z2. What about Z2 plus Z1? Z2 plus Z1 is nothing but Z2 we have minus 5 plus Z1 we have 6 plus I into, what is the imaginary part of Z2? It is 9. What is the imaginary part of Z1? It is 8. So we will get the answer as minus 5 plus 6 is 1. 1 plus I 70. Both are same. So commutative law says that Z1 plus Z2 will be equal to Z2 plus Z1. Clear? Next one is associate. What is that? Z1 plus Z1 plus Z2. That means we are writing the, not Z1 plus Z2 plus Z3. So we are adding Z2 plus Z3 first. We should add first brackets. Okay. So first we should add Z2 plus Z3 and add those answers to Z1. This will be equal to Z1 plus Z2. That is, if we add first Z1 and Z2 and add the answer to Z3, both will be same. It is called associative law. Okay, just changing the brackets. Now, next one is additive identity. What do you mean by identity? That is, here it is addition. If you add something with a complex number, you have to get the same complex number. That is called identity. Okay. So what you should add? You should add 0. Only then you will get the same complex number. So 0 is the additive identity. Next one is additive inverse. What do you mean by inverse? If you add something to the complex number, the answer should be 0. What you should get? If it is positive, it should be negative. If it is negative, it should be positive. Only then we will get 0. So minus z is the additive inverse. Clear, children? Suppose if you take this, z is equal to 6 plus I8. What will be minus z? It is nothing but minus 6 plus I into minus 8. Okay. So that is minus 6 minus I8. This is minus z. If you add this, 6 minus 6 is 0. 8 minus 8 is 0. We will get answer as 0. Okay. So additive inverse is minus z. Additive identity is 0. Clear, children? So these are the properties in addition. Okay. So moving on to the next concept. Next one is difference or subtraction of two complex numbers. So there are two complex numbers, z1 equal to a plus ib and z2 is equal to c plus id. How to subtract? The same as in addition. So subtract the real numbers. So these are the real numbers a minus c. So z1. So take the real part in z1 minus, next is z2. So take the real part in z2. So a minus c plus I into, what is the imaginary part in z1? B. What is the imaginary part in z2? It is d. B minus D. Okay. Z1 minus Z2 is equal to A minus C plus I into B minus D. So this is the way you have to subtract the complex numbers. Clear? Now, for example, we have Z1 equal to 6 plus 3i and Z2 is equal to 2 minus I. What is its subtraction? We note it as Z1 minus Z2. So we will subtract as 6. 6 is the real number in Z1 minus, what is the real number in Z2? It is 2. Plus I into, what is the real number in imaginary number in Z1? It is 3. Minus, here it is 2 minus I. This can be written as 2 plus I into minus 1. Okay. Here the coefficient is 1. So in order to write it as a plus ib, I am going to convert this as 2 plus I into minus 1. So this is b. This is b, which is the imaginary part. So it is 3 minus minus 1. Okay. So 6 minus 2 is 4 plus I into 3 minus into minus is plus 1. So we will have 4 plus I4. Okay. So this is the way you have to subtract. Okay. So suppose if you are subtracting Z2 minus Z1. Let us check whether it is same or not. So Z2 minus Z1 means first we have to take the real part in Z2. Who is that? It is 2 minus, what is the real part in Z1? It is 6 plus I into, what is the imaginary part in Z2? It is minus 1. What is the imaginary part in Z1? It is 3 minus 3. Okay. So it is 2 minus 4 is 2 minus 6 is equal to minus 4. Minus 1 minus 3 is minus 4. Minus 4i. Is it same? No. So addition holds the closure law, but in subtraction it is not same. Z1 minus Z2 is not equal to Z2 minus Z1. When will they be equal? Both the real numbers should be equal and both the imaginary part should be equal. Here it is not the same. One is positive and one is negative. So they are not equal. Clear, children? So now next we will be seeing multiplication. Multiplication of two complex number. So you have two complex number, Z1 equal to A plus IB and Z2 is equal to C plus ID. We have to multiply Z1 into Z2. What is Z1? It is A plus IB. Z2, it is C plus ID. Okay. Now first we will be multiplying with A. A into C, A into ID. So A into C, AC plus A into ID. So I, AD. Okay. Next, this IB into C, IB into D. Okay. So IB into C is IBC plus IB into ID, I into I, you will get I square, B into D is BD. Okay. So AC plus IAD plus IBC. What is I square? I square, we all know that it is minus 1. Okay. So now we will have AC plus IAD plus IBC plus into minus is minus, minus BD. So you can write this as AC minus BD. So this is the real part plus I into what is the imaginary part? AD plus BC. Okay. So this is the way you have to multiply. So the multiplication is same as multiplying any numbers, that is any linear equation x plus 3y or x plus 6y. In the same way you have to multiply this. The answer will be AC minus BD plus I into AD plus BC. So if you remember this formula, you can apply it directly or you can just multiply this way. Okay, you can apply this formula and find, or multiply this directly and find out the result. So the formula for multiplying is Z1 Z2 is equal to AC minus BD plus I into AD plus BC. Clear, children? Now let us do this for an example. What is Z1? 6 plus 3y, and Z2 is 2 minus I. We have to find out Z1 into Z2. So 6 plus 3I into 2 minus I. Okay. Now I am going to multiply first in this way and check the result by applying this formula. Okay. So now I am going to multiply 6 with 2 and 6 with minus I. So 6 into 2. 6 into 2 plus 6 into minus I. Next one is 3I into 2, 3I into minus I. So 3I into 2 plus 3I into minus I. Okay. So 6 into 2 is 12. So 6 into minus I. So plus into minus is minus. Minus 6I. Here first multiplying the numbers. 3 into 2 is 6I. There is an I. Next here you have a negative sign. So plus into minus is minus. Okay. So minus 3. I into I is I square. Okay. So 12 minus 6I plus 6I minus 3. What is I square? I square is minus 1. Okay. So now we will get 12 minus 6I plus 6I minus into minus, it is plus 3. Okay. So now minus 6I and plus 6I gets cancelled. So it is 12 plus 3, it is 50. Okay. So this is the result for 6 plus 3I and 2 minus I. Let us apply the formula and check whether we get the same result. Z1, Z2. So here A is equal to 6. B is equal to 3, C is equal to 2 and D is minus 1. D is equal to minus 1. What is Z1, Z2 according to the formula? AC minus BD plus I into AD plus BC. Okay. So A into C. So 6 into 2. So 6 into 2 minus, what is B into D? It is 3 into minus 1. Okay. Plus I into AD. AD means 6 into minus 1, which is minus 6, plus B into C. B into C is 3 into 2, it is 6. So it is 6 2s are 12, minus into minus, you will get plus, it is 3. Okay. Plus I into minus 6 plus 6 is 0. So you have plus 0i. There is no imaginary part. So it is real. Okay, 12 plus 3 is 50. We don't have imaginary part in this. So we can see multiplication will always not be a complex number. You will get real numbers also. So in multiplication, you have real number answer also. You have real number solution and you will be having complex number solution when you are multiplying. This is one example for that. Clear? So moving on to the next topic. Properties of multiplication of two complex numbers. So what are the properties? What are the properties? In the same way you have closure law. Closure law means if you multiply two numbers, it will be a complex number. So if we got 15 here, so 15 can be written as 15 plus I 0. So you can convert this to a complex number. So multiplication is all closure law holds for multiplication. Now commutative. What is that? If you multiply Z1 and Z2, you will get an answer. The same answer will be for Z2 into Z1. So multiplication is commutative. Next one is associative. Associative means changing the brackets. Z1 into Z2 into Z3 will be equal to Z1 into Z2 into Z3. Okay. So this means first you have to multiply Z2 and Z3 and multiply the answer with Z1. It will be same as multiplying first Z1 and Z2 and multiplying the answer with Z3. So that is called associative. Just changing the brackets. Next one is multiplicative identity. What do you mean by that? If you multiply with something, you should get the answer as the same. That is same complex number. What you have to do? You have to multiply with 1. Okay. So 1 is nothing but a number which we multiply with a complex number. We'll get the answer as Z. Okay. Next one is multiplicative inverse. Inverse means we have to multiply with some complex number to get the answer as 1. Who is that? It is nothing but 1 by Z. If you multiply Z with 1 by Z, you will get the answer as 1. So this we will learn multiplicative inverse 1 by Z at the end of this session. Okay. Next one is distributive law. Here distributive law means both multiplication and addition will be that. That is Z1 into Z2 plus Z3. That means first add Z2 and Z3 and multiply the answer with Z1. Okay. This will be equal to Z1 into Z2 plus Z1 into Z3. What do you mean by that? Multiply Z1 and Z2. Keep that answer. Multiply Z1 and Z3. Keep that answer. So you have to add both the answers. It will be equal to this left hand side. That is called distributive law. Clear, children? So moving on to the next topic. It is nothing but division of complex number. Okay. So slowly we are moving on to the complex part. Okay. So it is Z1 equal to 6 plus 3i. Z2 is equal to 2 minus I. We are going to divide Z1 by Z2. So it is 6 plus 3i divided by 2 minus I. How to divide? Here what we will do, we will multiply and divide by 2 plus I. If there is a negative sign here in the denominator, take a positive. Negative, convert to positive. If it is positive, convert to negative and multiply and divide. So it is 2 plus I and 2 plus I in the numerator and denominator. So you will get 6 plus 3i into 2 plus I. In the numerator you have 2 minus I into 2 plus I. This is a minus b into a plus b. What do you know? A plus b into a minus b is a square minus b square. The same formula we are going to apply it for complex numbers also. So in the numerator we have 6 plus 3i into 2 plus I. In the numerator it is 2 minus I into 2 plus I. First if we multiply the numerator, so 6 into 2 into 6 into I. So 6 into 2 is 12 plus 6 into I is 6I. Then in the denominator, not in the denominator, in the numerator, next we are going to multiply with 3i. 3i into 2, 3i into I. So 3i into 2 is 3 into 2, it is 6 into I. So you will get 6i plus 3i into I. So it will be 3i into I is I square divided by, this is a minus b into a plus b. We got the answer as a square minus b square. So what is a? A is 2. So 2 square minus, what is b? B is I. So it is I square. A square minus b square. So now we have 12 plus 6i plus 6i is 12i plus 3 into, what is I square? I square is minus 1 divided by 2 square minus I square is minus 1, which is equal to 12 plus 12i plus into minus is minus 3 divided by 2 square is 4, minus into minus is plus. So plus 1, which is equal to 12 minus 3. Subtracting the real numbers, real part, 12 minus 3 is 9 plus 12i divided by 5. You can write this as 9 by 5 plus 12 by 5i. So this is also a complex number. So division of number will be a complex number. Clear children? How to divide it? Clear? So moving on to the next important topic in the next page. Important one. It is nothing but power of I. What do you mean by I? How do you call I? I is called iota. Okay. We are going to learn the power of I. So what is the value of I? I is nothing but root minus 1. Okay. So I takes the value root minus 1. So if you square on both sides, I square. So if you square it on both sides, what will happen? This power 2 and square root gets cancelled. So we will get minus 1. So I square is minus 1. What about I cube? I cube can be written as I square into I. What is I square? I square is minus 1 into I, which is equal to minus I. So I cube takes the value minus I. In the same way, I power 4. How to write I power 4? This 4 can be written as 2 into 2. So you can write I square into I square. What is I square? I square is minus 1 into minus 1. So minus 1 into minus 1 is plus 1. So I power 4 is 1. What about I power 5? I power 5 can be written as I power 5 is 3 plus 2. So I power 3 into I power 2. So if there is a power, if this is the base, if the base is same, you can add the powers. So 5 can be written as 3 plus 2. So it is I power 3 into I power 2. So what is I power 3? I power 3 we already found out, it is minus I. What is I square? I square is minus 1. So minus into minus is plus, I into 1 is I. Okay. Next, I power 6. How do you write I power 6? I power 6 is 2 plus 2 plus 2 or 3 into 2. 3 into 2 is 6. So, how do you write this? I power 2 into I power 2 into I power 2. Okay. What is I square? It is minus 1. I square is minus 1. It is minus 1. So if you multiply minus 1 3 times, the answer is minus 1. So I power 6 is minus 1. Okay, children? In the same way, you can find out I power minus 1. How to find out I power minus 1? I power minus 1 is nothing but 1 by I. So what we will do? We will multiply and divide by I. Okay. So it will be I divided by I into I is I square. So what is I square? It is minus 1. So I divided by minus 1, it is minus I. So I power minus 1 is minus I. In the same way, I power minus 2. It is nothing but 1 by I power plus 2. What is I square? I square is minus 1. So it is, answer is minus 1. The same way, I power minus 3, it can be written as 1 by I power 3. What is I power 3? I power 3 is minus I. So we can write 1 divided by minus I. This can be written as minus 1 by I. I took the negative to numerator. So now what we have to do, if there is a I in the denominator, we have to multiply and divide by I. So minus 1 by I into I by I. So minus 1 into I is minus I into I is I square. I square is minus 1. So minus I divided by minus 1. Both the negatives gets cancelled. I by 1, it will be I. So I power minus 3 is I. Okay. In the same way, I power minus 4. It can be written as 1 by I power 4. What is I power 4? I power 4 is 1. So 1 divided by 1 is 1. So I power minus 4 is 1. So now we know how to find out the power of I, that is iota. Next we will see the general form of iota, power of I. In general, for any integer k, we can say I power 4k is 1, I power 4k plus 1 is 1, and I power 4k plus 2 is minus 1, and I power 4. So this is not 1, and sorry, this is I. This is I. That is I power 4k plus 1 is I. I power 4k plus 2 is minus 1. And I power 4k plus 3 is minus I. Okay. So this is the result we will get. Just memorize this and remember these values so that you can easily find out the power of I. Suppose they are asking for I power 26. How to write this 26? So here all are in 4, 4k plus 1. So divide by 4. 6 4s are 24 and the balance is 2. So I power 26 is nothing but 4 into 6 plus, what is the remainder? It is 2. So it is of the form I power 4k plus 2. So what is I power 4k plus 2? The answer is minus 1. So which is equal to minus 1. Another example, I power 33. So let us divide 33 by 4. 8 4s are 32. Balance is 1. So I power 33 can be written as 4 into 8 plus 1. So which is of the form 4k plus 1. The answer is I. So I power 33 is I. So even though you have higher powers, with using this formulas, you can easily find out the value of I with higher powers. Another example, I power 44. How do you write 44? In 4 table, it is 4 into 11. Okay, there is no remainder. Exactly divisible by 4. So it is of the form 4k. I power 4k is 1. Okay. Last example, I power 39. So let us divide 39 by 4. How many times? 9 fours are. 9 fours are 36 and the balance is 3. So it will be I power 4 into 9 plus 3. That is 4k plus 3. 4k plus 3, the value is minus I. Okay. So after that we no need. I power 4k plus 4, it is nothing but it goes to 4k. It is divisible by 4. So only for these 4 values you should remember the powers. I power 4k is 1. I power 4k plus 1 is I power 4k plus 2 is minus 1. I power 4k plus 3 is minus I. If you remember these 4 values, you can easily find out all the powers of I. Okay children, clear? So moving on to the next important topic, the square roots of a negative real number. Okay, we all know that root A into root B is equal to root AB. What we will be doing in 10th standard? If there are two roots, we will multiply the values and take square. So this is true for if AB is greater than 0, or if A greater than 0 and B less than 0, or if A is less than 0 and B is greater than 0. So this is true for this condition. Suppose if both A and B are negative, that is A is less than 0 and B is also less than 0. This if both are negative real numbers, then this condition doesn't hold. Okay. So root A into root B will not be equal to root AB. If it is 0, if A and B are 0, then root A into root B will be root AB, which is equal to 0. Okay. Now let us check this. Why we are not getting this equality? Okay. So we all know that root of minus 1 is nothing but I. Also, I square equal to minus 1. So these are all known already. So I takes the value root minus 1. If you take squares on both sides, you will get I square equal to minus 1. So now take I square. I square is nothing but I into I. So what is I into I? I is root minus 1. Okay. So I substitute the value of I as root minus 1. What we all know, root A into root B is equal to root AB. But I am saying that if both are negative, here both are negative, this doesn't hold. Suppose it is holding, that is root A into root B is equal to root AB. Okay. So I am assuming a contradiction. What contradiction means? Suppose even though it is negative, let me assume root A into root B is equal to root AB. So what we can do, we can write it as root minus 1 into minus 1. What is minus 1 into minus 1? It is 1. So root 1 is 1. What we are getting? I square equal to 1. But what we have already known I square equal to minus 1. So this is a contradiction. Why we got the contradiction? Because we assumed that root A into root B is equal to root AB for all type of number, even though it is negative. So we are getting a contradiction. So root A into root B is not equal to root AB when A is negative and B is negative. Clear, children? So you have to remember this concept. Okay. So this is equal for all other type. If both A and B are positive, if one of A and B is positive, this condition holds. If both are negative, this doesn't hold. Clear, children? So moving on to the next topic, which is an important topic, identities. Okay. So identities, it is very simple. What is that? Z1 plus Z2 whole square is Z1 square plus 2Z1 Z2 plus Z2 square. If you look at this, you all know the formula. A plus B whole square is A square plus B square plus 2AB. The same formula. This is also a minus b the whole square is a square minus 2ab plus b square. So the same as this. Also this is also a plus b whole cube. A cube plus 3 a square b plus 3 ab square plus b cube. So the same formula is for complex numbers. What about a minus b whole cube? The same. A cube minus 3 a square b plus 3 ab square minus b cube. The same formula can be applied to the two complex numbers z1 minus z2 whole cube. Here also z1 square minus z2 square, that is a square minus b square is a plus b into a minus b. Okay. So the same formula is applied to complex number. So that I think There is no need to explain a lot in this. You all are familiar with these formulas. Okay. So moving on to the next topic. It is modulus. So this is an important concept in a complex number. What is a modulus of a complex number? Okay. So this modulus is denoted by, you have to write the complex number denotation as Z and draw two vertical lines to the left and right. This is the denotation for modulus. Okay. Suppose if z equal to a plus ib modulus z. So that is write z and draw two lines on the left and right. That is the denotation for mod z. It takes the value square root of a square plus b square. That's all. Okay. If Az is a plus ib, what will be modulus z? It is nothing but square root of a square plus b square. Clear, children? So, for example, suppose z equal to 4 plus I3. They are asking for modulus z. So, this is the denotation. Write z and put two vertical lines on both left and right. So, modulus z is nothing but applying the formula. It is a square plus b square. So, this is a and 3 is b. So, a square. A square is 4 square. B square is 3 square. What is 4 square? It is 16. And 3 square? It is 9. 16 plus 9 is 25. 25 is a perfect square. So you will get the answer as 5. So modulus of z equal to 5. This is the way you have to find out the modulus z. Just remember this formula to find modulus of z. Clear, children? So moving on to the next topic. Conjugate. So this is also an important topic. Conjugate of Z. So it is denoted by a bar symbol on top. Okay, Z bar. So it is very simple. Z bar means if it is A plus IB, Z bar will be A minus IB. That's all. If suppose Z1 equal to A minus IB, its conjugate. It is denoted by Z1 bar. It is nothing but minus will change to plus A plus IB. That is called the conjugate. So when we were doing division, what we did? Just we changed the sign and multiplied and divide. So it is multiplying and dividing by the conjugate. Okay. Learned? Clear? Next. Suppose for example you have Z1 equal to 4 plus I3. What is Z1 bar? It is nothing but 4 minus I3. Suppose Z2 is equal to 6 minus I7. What is Z2 bar? It is 6 plus I7. So this conjugate is very useful in division. Okay, while dividing, we took 6 plus 3i. In the division, we had 2 minus I. What we did? We multiplied and divide by 2 plus I. Who is that 2 plus I? It is the conjugate of 2 minus I. We have to change the sign in between and multiply and divide. It is called by, this is called as conjugate. Okay, this is very helpful while dividing. Dear children, now with modulus and conjugate, we have some important points. What are they? Modulus of Z1, Z2. So multiply Z1 and Z2, take modulus. Its answer is equal to taking the modulus Z1 separately, multiplying with modulus Z2. Both answers will be same. Z1 by Z2. After dividing, if we take the modulus, its answer will be equal to modulus Z1 divided by modulus Z2. Take the modulus and then divide. Okay. That is also same. Next, Z1, Z2 bar. That is conjugate of Z1, Z2 is equal to conjugate of Z1 into conjugate of Z2. Okay. We take the conjugate separately and multiply. Answer is same. Multiply and then take conjugate. It is also same. Now here fourth one. So just note this. It is very important. So that is Z1 plus Z2 conjugate is Z1 conjugate plus or minus z2 conjugate. So in between you can have either plus sign or minus sign. So just note it down clearly. Z1 plus Z2 conjugate is equal to Z1 conjugate plus or minus Z2 conjugate. So when we deal examples and problems, we will know this clearly. Okay. Next one is Z1 by Z2 conjugate. So dividing this Z1 by Z2 and after taking conjugate, it will be equal to Z1 conjugate divided by Z2 conjugate. First you have to find out the conjugate of Z1. Then find the conjugate of Z2 and then divide. Its answer is same as after dividing taking the conjugate. Okay, clear? So these are the important points related to modulus and conjugate. Note down this point, take a screenshot or write it down. Okay, so moving on to the last topic, very important topic, multiplicative inverse of a complex number. How to find out the multiplicative inverse? So its formula is 1 by z. So 1 z into 1 by z is 1. So this 1 by z is called the multiplicative inverse. It can also be written as z to the power minus 1. Who is that? It is nothing but z conjugate divided by modulus z whole square. Now let us derive this formula. Okay. So we took a complex number z is equal to a plus ib. Okay. What is 1 by z? So 1 divided by a plus ib. How we will divide? We will take a conjugate of this. So if it is plus, we will multiply and divide by a minus ib. So a minus ib divided by a minus ib. So let us write 1 into a minus ib is same. So it is a minus ib. This is of the form a plus b into a minus b or x plus y into x minus y. What is its answer? You all know that it is x square minus y square. A plus b into a minus b or x plus y into x minus y. Its answer is x square minus y square. So here also the same. It is a plus ib into a minus ib. So it will be a square minus what is another value? It is ib square. Okay. So we will get a minus ib divided by a square minus I square b square. Okay. So we will get a minus ib divided by a square minus what is I square? It is minus 1 b square, which is equal to a minus ib divided by a square. Here minus into minus is plus b square. Okay. So what is a minus ab? It is nothing but conjugate of z. Z bar. Z bar is nothing but conjugate of z is nothing but a minus ib. So instead of a minus ib, you can write z conjugate divided by who is this a square plus b square? We all know that modulus z is nothing but square root of a square plus b square. Here you don't have root. So just square on both sides. So if you go square on both sides, the square root and power 2 gets cancelled. So modulus z whole square will be equal to a square plus b square. So instead of a square plus b square, you can write modulus z whole square. What we got? From 1 by z, we got this. Okay. So just cross multiplying 1 into mod z square. Is mod z square equal to z bar. Okay. So either you can remember this concept or this concept. So this is the relationship between modulus z and conjugate z. Okay. So you have to remember inverse of z is nothing but z bar by mod z square. Okay. So using this formula, you can find out the modulus, that is inverse of a complex number. So let us take one example. Z is equal to 3 minus 4i. Z is equal to 3 minus 4i. Not z. I'm sorry. Z is equal to 3 minus 4i. Now I want to find the inverse value for this. Okay. So what is 1 by z? Its formula is nothing but z bar divided by modulus z whole square. Now what is z bar? It is nothing but conjugate of z. What is a conjugate? Minus should be changed to plus. So it is 3 plus 4i. What is modulus is that? It is nothing but square root of 3 square plus 4 square. So 3 square is 9, 4 square is 16. So 9 plus 16 is 25. Square root of 25 is 5. So 1 by z equal to, what is z bar? It is 3 plus 4i. What is modulus z? It is 5 square. So you will get 3 plus 4i divided by 25. 5 square is 25. So separating 3 by 25 plus I into 4 by 25. So this is the inverse of this z. Okay. So to find inverse of a complex number, we can use this formula z bar by mod z whole square. Clear, children? So with this, all the concepts related to the complex numbers are completely done. Okay. So just revise one more time. So you will learn all the datas in the complex number. So it will be very easy to solve it. So this is not complex. It is very easy. Okay. So if you like my video, just show your support by subscribing and hit the like button. Clear, children? Also, if you are able to understand and if you are a good children, just share among your friends because sharing is a good thing. Clear? Thank you.